So students, we got this question. Let B be a non-zero real number and suppose we got f going from R to R is differentiable such that f of 0 is equal to 1 if the derivative f dash of f satisfies f dash of x is equal to f of x over b squared positive x squared for all x element of R, then which of these is or true? So you have to pick up the choices. Now let me give you those choices. If b is greater than 0, then f of x, or I would say the function is increasing function. This is A. Choice B, if b is less than 0, then f is a decreasing function. And choice C, f of x multiplied with f of negative x is equal to 1 for every x element of real number. And choice D is f of x added with f of negative x, or I would say added with negative f of negative x will give you 0 for every x element of real number. So now the choices that you see here, either one can be true or more than one can be true. So having given you that information, we will have to go and solve the question. So go through this question and you can pause the video and do it by yourself and then come back and see how the flow is. Okay, I hope you have got it. So let me move on. Now this is what is given. Okay, so this is the solution for this question. Solution given f dash of x is equal to f of x over b squared positive x squared. Now what I wish to do is I would rewrite this as f dash of x over f of x is equal to 1 over b squared positive x squared. Then I would integrate both sides. We get, so what do we get? Integral f dash of x divided by f of x times dx is equal to dx over b squared positive x squared. Now what is this? This is nothing but our popular ln x. So this is ln modulus of f of x is equal to, now what is this? This is nothing but our tan function. So probably I can write this here. This is liken to our integral dx over x, which is ln modulus x positive arbitrary constant c, and this is integral dx over x squared positive a squared, which is 1 over a tan inverse of x over a positive c. So these are the integrals that we are employing here. So this is equal to 1 over b tan inverse of x over b. You need to add the arbitrary constant c. Now what is given in the question? It is given that f of 0 is equal to 1. So I'm substituting here, x is equal to 0. What do you get? Ln modulus f of 0 is equal to 1 over b tan inverse of 0 over b positive c. Now this is 0, this will be 1. This in turn would give us c is equal to 0. If I take this as 1, therefore 1 will now be equal to, let me go to the next side. Okay, so we've got till here. Moving on. This is going to be giving us ln modulus f of x is equal to 1 over b tan inverse of x over b. Right. Now there is a popular formula. What is the formula? Ln a, you have a base e is equal to say sum b. This means a is equal to e raised to the power of b. So by this formula, you got f of x. In this case, we will have to retain the modulus. This is equal to e raised to the power of 1 over b tan inverse of x over b. Okay. Now, if I want to get rid of this modulus, I would have to rewrite this as plus or minus e raised to the power of 1 over b tan inverse of x over b. Okay. Now, we are given, okay, for all x, so for every x element of real number, you have f of 0 is equal to 1. This in turn would mean our function will only be positive e raised to the power of 1 over b tan inverse of x over b. Okay. So this is got. Now we have to locate the choices. Okay, we have to locate the choices. For locating the choices, we have to find out if f is increasing or decreasing. Okay, so for that you differentiate this with respect to x. We get, so f dash of x is equal to, differentiation of this would give you e raised to the power of 1 over b tan inverse of x over b times differentiation of tan inverse of x over b. That would give us 1 over b squared positive x squared. Okay. Now this is going to be greater than 0. Why? This is greater than 0. This is going to be greater than 0. So this means for every x element of R, our function, what is our function? Our f of x is increasing. It's always increasing. So go back to the choices. So this is ruled out. So this is okay for b greater than 0. Now we need to zero in either this or this. We need to check for these two values also. Now for that, go back to the function. Since f of x is equal to e raised to the power of 1 over b tan inverse of x over b, for x is equal to negative x, f of negative x is equal to e raised to the power of 1 over b. Now tan inverse of negative x, that's rewritten as negative, okay, x over b. So if I were to multiply f of x times f of negative x, that would give me e raised to the power of 1 over b tan inverse of x over b times e raised to the power of negative 1 over b tan inverse of x over b. Now a raised to the power of n times a raised to the power of m is a raised to the power of n plus m. So in this fashion you will get e raised to the power of 0, which is equal to 1. This in turn would mean f of x times f of negative x will be equal to 1. So clearly this also holds good. This also holds good. For sure you can verify that f of x negative x cannot be equal to 0. Okay, that is easily visible. So the choices would be A and C. That would be the choice for this question. So we will move on to the next one.